Hey everyone, this is Mr. Beckstrom, and today we're going to look at finding the real zeros of a function here. So looking at this function, this is a third degree polynomial because the highest degree is a 3, which means that we're going to have up to 3 real solutions. Now some of those may end up being imaginary, so we might not have 3 altogether. But since we're starting as a third degree polynomial, we really want to find at least one root using a method. We're going to be using the root theorem or the zero theorem here, rational root theorem, rational zero theorem, in order to hopefully find one. And then we're going to factor that out and get down to a quadratic. And then we can use one of our formulas that we can do factoring with. All right, so let's go ahead and get started. So we're going to use, again, the rational root theorem, which says that we're looking at all the factors of the constant, which is p. So all the factors of 9 are 1, 3, and 9, and plus the positive and negative version of each one. And then we're going to put those over all of the factors of q, which is the coefficient of the first term, the one with the highest degree, which is 7. So that's just going to be 1 and 7. And I guess, again, we're looking at all positive and negative answers there. So now I'm going to look at p over q, which is going to be a combination of all of the p's over all of the q's. So I'll start with 1 here and put it over 1. So 1 over 1 is 1. 1 over 7 is 1/7. Now I'll move to 3. 3 over 1 is 3. And 3 over 7 is just 3/7. And finally, the 9. 9 over 1 is 9. And 9 over 7 is 9/7. Okay. So now that I've done this, these are all, remember, plus or minus. So we got to look at both the positive and the negative of each one of these values. I'm going to go ahead and go to my calculator. I'm first going to go ahead and put in this equation. So that's 7x cubed minus 43x squared plus 69x minus 9. Enter. And I'm going to go to second window, make sure my independent is on ask, and then second graph. And now I'm just going to start putting these values in. So let's delete what I had before. So I'm going to check 1, negative 1, 1/7, 1 divided by 7, negative 1 divided by 7. And so positive 1/7 is going to be one of our solutions. So I'm going to write that down here. That's one of our roots. And then I'm going to keep going here. And we're going to do 3. Oh, there's another one. Remember, because we get a 0 back. And then negative 3. And then 3/7. Negative 3/7. 9. Negative 9. And 9/7. And negative 9 over 7. Okay, well, we got 2 rational real roots, so we can use those in order to solve this. So the first thing I'm going to do is synthetic division here. So I'm going to write down all the coefficients of each of the terms here from the original equations. That's 7, negative 43, 69, and negative 9. Now, if I was missing an exponent, for example, if it jumped from x cubed to a single x, I need to put in a 0 placeholder for the x squared term. But in this case, I have all of them. So that's going to be 7, negative 43, 69, and negative 9. All right, I'm going to give myself have an L-shaped thing here. And I'm going to divide. I'll do the 3 first. That way I don't have to deal with fractions, which are yucky. So the 3 here. So first we're going to bring down the 7. And then 7 times 3 is 21. So negative 43 and a positive 21 should be a negative 22. 3 times negative 22 is negative 66. Add these two together and I get 3. 3 times 3 is 9. And I add those together and I get 0, which is what I should get. So that there is one of my roots, which is 3. And remember, this polynomial is 1 degree less than the previous one. So the previous one is a 3rd degree. So this is a 2nd degree polynomial, or these are the coefficients of the 2nd degree polynomial, which would be 7x squared minus 22x plus 3. But what I'm going to do is I'm going to do synthetic division again with the 1/7. So 1 over 7, I know we're using fractions. Let's see if we can make this work. Bring the 7 down, and we're going to get a 7. 7 times 1/7 is just 1. Bring that down, you're going to get a negative 21. 1/7 of negative 21 is a negative 3. And add that together, or add those together, and we're going to get a 0. So now we went from a 2nd degree to a 1st degree. So this is just 7x minus 21. So far, I have the 3. So the factor that fits with the 3 is x minus 3 minus 3. And then I'm going to have the x minus 1/7 minus 1/7. And let's go ahead and solve this one before I do it. So remember, that one is just 7x minus 21 is equal to 0. And add 21 to both sides. We're going to get 7x is equal to 21. And finally, we're going to divide both sides by 7. And I'll get x is equal to 3. Oh, so 3 actually shows up twice. That's why we didn't see it by doing that. So that means that it has a multiplicity of 2. So I'm just going to put a little square term here. And now this is fully factored. And our roots are 3 with a multiplicity of 2 and 1/7. All right, if you have any questions, let me know. And have a great rest of your day. Thank you.